Okay, guys, Stat 1150 again. We're going to study something called z-scores. The goals of this video are pretty straightforward. First of all, I want to show you the formula. I want to show you how to calculate and interpret a z-score. Next thing we'll talk about is how we can use a z-score to detect unusual scores. Unusual usually means extremely high or extremely low. And then we'll look at an example how to calculate a raw score given its z-score. So let's say something. Let's say we had some summary statistics already taken, and let's say that I am focusing on ACT scores for students in my online stats class. And let's say that I've calculated this and I have 31 students in my class. The mean ACT is 21.8 and the standard deviation is 5.2. So what we can do with z-scores is, well, the primary function of a z-score is to determine how far from the mean in standard deviations that a score falls. Now, it's really not fair to just look at how far a score falls from the mean, because we have this measure of variation that determines being close or a long way away. For example, if the standard deviation gets bigger, then let's just look at an example. The standard deviation is 5. If I add 5 to this, then a score of 26.8, or if it's 5.2, be 27, is one standard deviation above the mean. But if I have a standard deviation of 10, add 10 to that, then 31.8 is one standard deviation above the mean. So when we're measuring how far something is from the mean, we need to consider a standardized unit in terms of the standard deviations away from the mean. Well, put all that together, you get the z-score formula, which is just to take the raw score, which in this example would be a student's ACT score, minus the mean over the standard deviation. So guys, the way this would work, the z-score for a student with an ACT of 28. So since the ACT is what we're focusing on, we can say that this is x equal 28. So therefore the z-score would be x minus x bar over the standard deviation. So our x in this case is the score again. We're trying to calculate the z-score of. The x bar, I forget, I think I said 21.8. And the standard deviation, I think I said 5.2. So when we put this in our calculator, we would need to put the numerator in parentheses. Let me clear this out so you guys can see. So 28 minus 21.8 divided by 5.2 gives me 1.19. This tells me that a score of 28 is 1.19 standard deviations above, because this is positive, the mean. Not too bad, right? What is the z-score for an ACT equal to 16? I don't know why I'm having such a hard time remembering the mean and the standard deviation. Guess it's a bozo moment. So put in the score of 16 minus 21.8 over the standard deviation of 5.2. So guys, really right here, all I need to do is just go second function entry. And the only thing I need to change is just to 28, from 28 to 16. And you'll see that we get a negative z-score here of negative 1.12. Now, why is it negative? Well, it's negative because the score is below the mean. So we can kind of make a generalization from this, can't we? If the score is bigger than the mean, then this is going to be a positive divided. Standard deviation has to be positive. So this is going to be a positive divided by a positive, give me a positive z-score. If the score is below the mean, then this subtraction right here is going to give me a negative number divided by a positive gives me a negative number. So we can summarize by saying a score of 16 is 1.12 standard deviations below the mean. What if a student has a z-score of 21.8? Now you might say, Dr. Darbro, you can't have an ACT of 21.8, they fall of 19, 20, 21. Let's just pretend, okay? So our z-score is 21.8 minus the mean of 21.8 divided by the standard deviation of 5.2 is 0. So this tells us that the score is no standard deviations above or below the mean because the score is exactly the same value of the mean. So our interpretation, we would say that an ACT of 21.8 is 0 standard deviations above or below the mean in standard deviations, of course. So guys, if we have a mean of 20 and a standard deviation of 5, I can tell you that a score of 18 will have a negative z-score. Why? Because it's below the mean. A score of 25 will have a positive z-score. Why? Because it's above the mean. And a score of 20 will have a z equal to 0 because that score is precisely equal to the mean. Pretty easy stuff, right? Bet you hope it stays this easy. Now, let's say that we have the following. An ACT has z equal to 2.00. What is the value of the ACT if the mean equal 21 and the standard deviation equals 5? So guys, again, the formula is what? The z-score is the score minus the mean over the standard deviation. So we know the value of the standard z-score here is 2. We want to know the value of the ACT, which we don't know, so we'll let that be x. We know the mean is 21, and we know the standard deviation is 5. Guys, multiply both sides by 5. So we get 10 equal x minus 21. Add 21 to both sides. So x in this case would be an ACT equal to 31. so the ACT, that has a z-score of 2, and we have this mean and this standard deviation, is equal to 2. Now, I want to go to Blackboard, and I want to show you something that I've uploaded and something we'll do quite often. So if you go to Content, you can see that there's a new folder called Data Sets. And I've uploaded a data set. I'll upload even more called IQ and Read. So I'm going to open it up. Maybe. I don't want to do any of that just yet. All right. All right, so I have this this data set that gives a reading score, an LSS score, the ACT, the student's IQ. This is a reading estimate, their gender, and we have the school district from which the student is taking classes. Now I want to take File and I want to save this on my desktop. And I just want to save it. Now I want to do some stuff with it. I want to get out of this, and I want to minimize this, and I want to minimize this, and I want to go to Google Chrome, and I want to go to my Stat Lab. And once I get to my Stat Lab, I want to go to Statcrunch. I want to go to the Statcrunch website. And I want to select a file on my computer. Choose the file. I put it on my desktop because I wanted it to be easy to find. And then I want to come all the way to the bottom and I want to load the file. Okay, now that we have our data in Statcrunch, we can easily go through and calculate the z-scores. So to do that, we're going to go to Data, Compute, and use Expression. Now the expression we're going to build, and so what I want to do here is I want to take, go over to Build, and I want to take a left parentheses. I want to take Read minus the mean. Let's go find it. And I want the mean of read. And then I want to, let's see, I want to divide that by the standard deviation. Where is it? I guess it's right there. Of read. I can, let's see, value's 10. I don't know what that means. So let's just go OK. And column label, let's call that Z for read. And go compute. Now, we've got a new column's been added, and you can see that the Z reads over here. You can see that some are negative and some are positive. Now what we can do is we can go to Stat in Summary Stat and do a column and just take a look at read. Okay, so I want to look just at the mean. So the mean is 59.6. So you can see that the read score of 94 is 1.48 standard deviations above the mean, which is 59.6. So all of these values here that are below 59.6 will have negative z-scores. All of them. And any line that has a value below 59.6 will have a positive z-score. Now, so what we can do is we can come in and do a quick summary stats just to follow up on something I talked about a little bit earlier. And we can take this z-read, and I just want to do the sum of the z-read, just to make a point, because the sum of z-scores is always 0. But if you're not careful, it can turn out to be a little weird looking. Now, when you look at that, it's so tempting to look at that sum and say, well, it's negative 1.55. Well, it's not, because within rounding, we have a total value that is very, very close to 0. This e to the negative 1.5, that's scientific notation. That tells us that we have to move this decimal place 15 places to the left and fill in with 14 zeros. So guys, within some numerical accuracy, well, within some rounding, we can see that the sum of the z-scores is actually 0. So just a point to ponder. Don't spend too much time pondering that. So keep this data set handy. I kind of want to get rid of some stuff for future use. I've got some things that popped up because of some errors, but you know, the z-scores again are very, very easy to find. And again, just as a summary, what do z-scores tell us to do? They tell us to take the score, divide them, subtract the mean, and divide by the standard deviation. Ultimately, a z-score tells us how far above or below a raw score falls from the mean in terms of standard deviations. Gang, that's all I've got in this video. We're going to be our focus about midstream in this semester will change from focusing on samples to taking a look at populations. Now, when that happens, we get into types of different things. Get into different notation for z-scores a little bit. Get into a little different formula with different symbols. But we'll cross that bridge when we get there. So take care.